Alrighty, dighty algebra. How you guys doing? Mr. Bulger here, coming to you with 13.4. Now, this is where it's not so pretty because we are going to be dealing with expressions that have different denominators and how we add and subtract them. Now, same like yesterday, the process is basically the same as fractions. So what we're going to need to find is use the least common multiple with these expressions. So we need to find what we can multiply in order to both fractions, top and bottom, in order to get the same denominator. Elena, don't lose heart. We can do this. Okay. Yes, first step is to factor the polynomial. So if it's quadratic, you just need to factor it, kind of break it apart. And then the least common multiple will be the product of the highest power of each factor. You'll see what I'm saying. I've got a handful of examples. But first, let's go over least common multiple again. So let's say we have 12 and 15. Well, if we're going to break these down, 12 is 2 times 2 times 3. And 15 is 3 times 5. So since 3 is shared, only multiply it only multiply that to find the least common multiple. So only multiply it one time. So what it means is since they each have 1, 3, I've got one here, I've got one here, we're going to need to multiply all the factors to find the least common multiple, but I don't need to multiply 2 times 2 times 3 times 3 times 5. I only need to multiply 2 times 2 times 3 times 5, and that's my least common multiple. That's what it means by the product of the highest power of each factor. Well, the factor here is 1, right? 3 shows up once each time. Sorry, that's really confusing. 3 shows up once each time, so I only need to include it once in the least common multiple. What that's going to look like for us is, let's say we have 9x cubed y and 3y squared z. Again, I'm going to need to factor my 9. I'm going to need to factor my x cubed and my y. Again, I'll need to factor 3y squared and z. So here's what I have. I've got 3 times 3 times x cubed times y. I could have said 3 squared, but it's easier to show numbers all laid out instead of, I don't know why I did it here and not here. I think I was just being lazy. What you should do is multiply it all the way out times x times x. Don't be lazy. Okay. Now, what I've done is I've underlined each matching multiple. So I've got a 3 here and a 3 here. So instead of multiplying, well, I've got 2 3s over here. Oh, but I also have a 3 over here. I don't need to include all 3 of these factors, all 3 of these 3s in my least common multiple. One of them, it's like they kind of cancel each other out, or they count for each other. So I'm only going to have 2 3s, right? Because that's the highest amount of 3s in either factor in the least common multiple. Now, I do need to include all 3 of my x's. I need to include 2 of my y's because that's the highest power, that's the highest amount I have in either of these factors. And then I only have 1 z. So the least common multiple between these two different terms is 9x cubed y squared z. This is my LCM. So again, factor it, break it down. And then include in the least common multiple the highest power of each different factor. So I've got 3x's, boom. Yes, I do have 1y here, but the higher power is this one. The higher amount is y squared, so I need to include that. I do have a 3 here, but the higher amount of 3's is I have 2 over here, so I need to include 2. I hope this makes sense. We've done a lot of least common multiples in past years, so if this doesn't make sense, I hope it's familiar enough territory where you guys are like, well, I know how to do it. So now what we're going to do is apply this to rational expressions. Again, our aim is to make the denominators our least common multiple before we add or subtract. In fact, that's what we have to do, because otherwise you can't add and subtract fractions, right? So let's say I've got, so this is a simple one. 3 over 2a, that's the letter A, plus 5/8. Okay. Well, now what I need to do is I need my numbers on the denominator to match. So I'm going to have to multiply this by 4 in order to get to that number 8. But I also need to multiply this by a in order to have the same denominator. Okay, so I'm going to multiply this first one by 4, top and bottom. Remember, what you do to the bottom, you have to do to the top. And then 5/8, I'm going to multiply both by a. Okay, that's going to give me 12, right, because I multiplied that by 4. 12 over 8a plus 5a over 8a. Now we're at the point where we were yesterday, where now we can combine these like terms. My denominator is going to stay the same, right? But my numerator turns into 5a plus 12. And since we can't factor anything from 5 and 12, this is simplified. Okay, here's another example. Oh, rather, that's just showing what the least common multiple is. 2a cubed, right? Because 8 is 2 cubed. Okay. Here's another one. So I've got 3 terms here. 2x minus 5 over 3x plus x minus 1 over 2x plus 5x plus 6 over 12x squared. Okay, again, I need to find the least common multiple. Well, as far as the numbers in the denominator, we know that all of these numbers go into 12. So that's easy. We also know that our variables are all the same letter. Now we just need them to be the same power. So this guy, in order for this to be 12x squared, I need to multiply this by 4x. And again, what I do to the bottom, I have to do to the top. Now when I do that to the top, when I multiply this by 4x, I'm going to distribute 4x here and here. So again, my least common multiple is 12x squared. So I'm going to multiply 4x by the top. This is the first fraction here. And I'm going to multiply this guy by, let's see, in order to get 2 to a 12, I need to multiply it by 6. I did that wrong. That should be 6. And then this can stay the same because this is the denominator to which I'm adjusting all these. And in that case, I don't know if this is the right answer, but basically what we would do is we'd have to multiply all the way through, combine like terms, la 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 la. What I have here is what it's going to look like after we do that. Now what I'd probably have to do is simplify again, see if there's anything that I could divide, but that's the basic premise. Okay. All right. Now again, when we subtract these guys, we're going to rewrite subtraction as adding the opposite, right? I talked about that yesterday. Keep, change, change. Again, we first find the least common multiple. Hey, why is that blurry? So let's say we have this guy. X minus 3 over x plus 1 minus x minus 4 over x plus, that's an x, plus 2. So because this is a different factor than this, my least common multiple is going to be the product of this times that. There. Now, notice what I didn't do is I didn't FOIL this and multiply it all the way out. I'm just going to try to, so this one, I need to multiply both top and bottom by x plus 2. Bing, bing. And just the opposite for this guy. I need to multiply both top and bottom by x plus 1, right? That'll give me the same denominators, and then I can add or subtract. So I've done that here. I've written it all the way out, but I haven't yet changed my my subtraction. I haven't yet added the opposite. Okay, all I've done is I've applied I've done the first step, which is to find the LCM and make them with the same denominators. Okay, right? I've multiplied by the least common multiple, right? I've multiplied to make the least common multiple. Okay, now I've factored this all the way through. I FOILed it out, x squared plus 2x minus 3x minus 6, right? So I've done that for both top and bottom, or rather for both fractions. I've factored the numerator. What I did was I did FOIL, right? First one's outside, inside, last, right? A lot of multiplication. I think that goes back to chapter 9. Okay. Now what I've done is, after combining my like terms here and here, I've added the opposite. So I'm now applying this negative to each of these individual terms on the numerator. And now I'm adding the opposite. So I'm going to keep my denominator in its factor form. I'm not going to FOIL it out. You'll see why in just a little bit. Okay, now I'm going to combine like terms again. X squared plus negative x squared, well, those cancel out. Negative x plus 3x, well, that'll give me 2x. And then negative 6 plus 4 is negative 2. And then we'll see if I can extract any, right, after removing the 2 from the top. That's just going to give me this after I've combined my like terms. All right, guys, I hope this helps. I know it's difficult with the denominators, the least common multiple. If you guys have any questions, please let me know or save them up for our Zoom chat tomorrow. Otherwise, love you. Bye.